So look at the success criteria. You got to determine and describe the features of a cubic polynomial, and you've got to sketch if they're in those forms. So y equals x cubed looks like this. So instead of with a quadratic, when you subbed in negatives, it would go up because anything negative squared is anything cubed that's a negative becomes a negative. Did you all write down the point of inflection? I do a little sketch. It's the point where it goes from positive down to negative. It's flipping. So these are other types of points of inflection where the curve goes from concave down to concave up. So this is a curve up. It's curved up, and there's a point where it goes to curve down. So what happened here, everyone? There's a negative out the front. So what's happened to the graph? It's flipped. So it no longer goes from top right down to bottom left. Now it starts top left down to bottom right. Okay? So that's what a negative does. All right, so next is a cubic in this form. It looks similar to, remember the turning point form for quadratic? So in this form, there's no turning points. There's a point of inflection, and there's only one x-intercept. Okay, let's sketch this one. We've got the x-axis and the y-axis. All right, what do we think the 1 does? So if I sub in 0 for x, y equals 1. It's basically just shifted our graph up. And what's the x-intercept? I need to get rid of the 3. So I do the cube root on both sides. The cube root of -1 is -1. Okay, so this one's tricky. What form is this? The inflection point form. I'm calling it that. So what's the something wrong in the brackets? So we could rewrite it as -x plus 3. Or you could write it as... So what is... Tell me what's happening. 3, 1. What does the -1 do? Or the minus, sorry. So it starts over here. We should find the intercepts. Y equals 0. So that's 4, 0. Y-intercept, x equals 0. All right, the third form is this form where you have 3 brackets and a constant. This form is important to show basically the intercepts straight out. So this is one intercept for x, one intercept for x, another intercept for x. So it crosses the x-axis at A, B, and C. You have to note that this form, it has 2 turning points. So one turning point, one turning point. If k is positive, again, it starts low and moves up. If it's negative, it does the opposite. So let's do an example of this form. Again, draw the Cartesian plane. So if we go x-intercepts, y equals 0,
So one of these things, because they're all being multiplied, has to equal 0. And that's what gives us, if we bring that 2 over, that's the first intercept. So x equals 2. And it's starting low, starting down here, going up, around, like that. We can also get the y-intercept, which would be all of these numbers multiplied, which is -8. 0 minus 8. Not to scale, but that's the sketch of the third form.